Hello everyone, welcome to Module 4. I wanted to take a little bit to talk about what to expect in this module before we jump into it. This module will cover 2 chapters in your textbook, chapters 4 and 5. As you can see, this module is broken up into more parts than some of the previous modules have been. I want to talk a little bit about the reason for that and kind of what to expect as you go into these different parts. Part of the reason is we are covering 2 chapters, and part of the reason is as especially we get into chapter 5, the material becomes important, the initial material becomes important for the later material. So what this means is that we'll have the subsections will be smaller, and the idea is that you'll kind of master the material in that subsection before moving on to the next one. Within those subsections, the videos will be shorter and the activities will be shorter. So just be aware of that. So there are more subsections, but they will be covering less material. Also, I did want to mention that some of the videos in this module were recorded in a classroom during a previous semester. Because of that, we will not always have kind of this introductory section for those pre-recorded modules. So look for section 4.3, 4.4, and 4.5. We'll just jump straight into the material, whereas 4.1, 4.2, and 4.6 will be recorded in the way that we typically do for this class. Okay, so the learning objectives for Module 4.1 are listed here. Identify groups and columns of the periodic table and the following groups with special names: alkali metals, alkaline earth metals, halogens, and noble gases. Know the properties characteristic of these groups. Identify regions of the periodic table where metals, nonmetals, and metalloids would be located. Identify the region where transition metals are located. Know the properties of metals and nonmetals. Okay, so let's go ahead and get started. I want to talk a little bit about some historical things here to set up our discussion of the periodic table. So I want to start with atomic theory. So this idea is over 200 years old now, and the idea is that each element is composed of tiny indestructible particles called atoms. All atoms of a particular element have properties that are that will distinguish them from atoms of other elements, and that atoms combine in simple whole number ratios to form compounds. These are the ideas of atomic theory. This theory is very old. At a time, it was discovered at a time when we were not able to directly observe these sorts of things. But now, as we can see, that is possible. So here we're showing some atoms. So these are atoms that were assembled to form the initials of a large company. And lots of places are able to do this. We're able to see atoms now. So what we'll be looking at here is how this idea of atoms and elements works. So when this idea was discovered, it had an effect on how people thought about matter. And so I want to talk again a little bit about the history of this. So from ancient times, there were about 11 things that were known that we would now refer to as elements. Some textbooks would say 10. They are excluding platinum. People knew about platinum, several years ago, but Europeans didn't know about it till more recently. Okay, so I would say 11 elements have been known since ancient times. During this time period, from 1300 to 1700, basically over a span of 400 years, there was about an element discovered every 100 years or so. And then into the 1700s, so in basically the course of someone's life, the number of elements more than doubled what had previously been known. And then again, here we're kind of getting to the definition of an atom. The modern definition of an element was made during this time. So the idea that elements are things that cannot be simplified any further in 1789. And then, of course, the atomic theory we just talked about in 1805. Kind of shortly, I guess, in that same time period. So this was in the course of one person's life. Now we're up to discovering elements at a rate of at least one a year. So by 1869, there were a total of 62 elements that have been confirmed. Now, the idea here isn't that you memorize these dates. This is not a history class. That's not the idea. Just kind of understand how this idea of what an element was began to change. And as it did change, the discovery grew more rapid. Okay, so why is 1869 important? Let's go ahead and talk about that. There were enough elements by this point in time that it was possible to find patterns in those elements. And many people tried to do this. The person that got the most credit was Dmitry Mendeleev. He was looking for patterns. He was actually trying to write a textbook and trying to make it easy to understand for his students. And in so doing, he found a pattern that no one had found before. And here we're showing an arrangement of the elements. We'll talk in a bit why this particular arrangement, but you can see there are numbers here. And if you put those numbers in order, we end up seeing these patterns that keep repeating. So the colorations here are referring to similarities. Okay, so we can see this repeating pattern is going on. Now, again, I said many people were doing this, but one person, Mendeleev, got kind of all the credit. And the reason he got so much credit for his discovery of the periodic table is he decided that there were some missing elements and that somebody would discover them and that they would have certain properties. So he predicted these three elements. He called them Eka aluminum, Eka boron, Eka silicon, and this Eka thing is meaning that they are going to, it's something related to where they are in correspondence with these other elements of the periodic table. And then when these were discovered, some of them shortly after his prediction, so we're showing when they were discovered here, they were found to have properties very similar to what he had predicted. So we're seeing that here with germanium. And so this is what he predicted. These are the properties that it had. Okay, so very, very similar. Because he was able to make those predictions, people put a lot of stock in what he discovered. They believed what he had discovered, and so we now have the periodic table. So let's talk about the periodic table, and I'm going to talk about a couple of things here. There's a lot of things that we want to be able to recognize in the periodic table. There are, first of all, there are some different arrangements we can talk. So there are, first of all, there are two kind of ways of looking at this. We have, as we go across, we have some numbers, and as we go down, we have some numbers. So let's talk about the ones that are going across first. You'll notice there are two sets of numbers. So we have 1A, 2A, 3A, so the ones with the A's or the B's on them. And then we also have just going from 1 up to 18. So these are actually competing numbering systems. And this periodic table is showing both of them. You just want to be able to, with whatever periodic table you are provided with, find what you need from the numbering system on that periodic table. But these are numbering what we call the groups. So these are numbering these columns of the periodic table. So the number at the top is the number of the group. So the columns are what we call groups. And then the numbers over here are numbering the rows. The rows are what we call periods. Okay, so we have groups going across, periods going down. What does that mean, to be a group or a period? Well, within a particular group of a periodic table, we will often have very similar properties. As you go down this group 8A, for example, you have a lot of similarities. As you go down group 1A, you have a lot of similarities. We'll talk in a little bit more detail on the next slide about some special groups that are very similar. So within a group, you often have very similar properties. The periods are telling us when those properties repeat. So going from, say, period 1 to period 2, if you are in the same group, you're saying, okay, this is the period at which we have this property repeating. So how the periodic table is saying, periodically, we have the same thing occurring again. So that's the meaning for the word period for these. You'll notice we also have different colorations on this particular periodic table, and you can see the key up here. The yellowish color is showing the metals. You'll see that most of the elements are metals. Not something that many people expect to be the case, but that is the case. And the green ones, so a few here in the upper right, and then hydrogen are the nonmetals. And then between them we have this kind of this staircase border where we have what are called the metalloids. So I want to talk a little bit about what we mean by metal, non-metal, and metalloid. And I think the easiest thing to talk about here are the metals. Metals have a few characteristic properties. Metals are very shiny. They are very malleable. They're good at conducting heat. They're good at conducting electricity. So those are 4 properties characteristic of metals. Non-metals, we say, do not have those properties. They would have usually the opposite of whatever those properties would be. So if you think about a metal, so a metal you can, for example, make into a wire or a coin or a piece of, maybe a piece of jewelry. Non-metals cannot do that. So if you imagine taking a piece of charcoal and making it into a wire, it would just crumble apart. So that idea of being malleable is not a property that the non-metals will have. So non-metals, we don't have a good way of characterizing them other than to say, whatever we say the metals do, then non-metals do not do that very well. And then we have the metalloids. The metalloids will tend to have some metal properties and some non-metal properties. And in fact, we can often turn them on and off. So we can make them act like a metal sometimes, make them act like a non-metal sometimes. And this is important in what we call semiconductors. So if you look at these elements, the one that you're probably most familiar with is silicon. So silicon is used in semiconductors. Semiconductors are the basis of all electronics in the world. So your computer, your phone, everything that you plug in operates on the idea of semiconductors, which is that you can turn them on and off. Okay, so the ability to turn circuits on and off is a property of the metalloids, which has been very, very important to the electronics industry in our life. Make sure you understand properties of metals, nonmetals, and metalloids, and where to find them on the periodic table. I want to look at another way of showing the periodic table. And we're showing the same information here for the most part, but we're focusing on some different things. So you can see we don't show the period numbers here, but you can easily count them down if you needed to. We're showing some of the group numbers. We're not showing all of the ones in here. But then we also have some names. So I want to talk about these names. There are some parts of the periodic table that have special names, and most of the time these are going to be groups with a few exceptions, and we'll go through all of these. So the first group are what we call the alkali metals. And the alkali metals do not include hydrogen. So the arrow is a little misleading here, pointing to, it looks like it's pointing to hydrogen. Imagine it's pointing around hydrogen. So these whatever kind of salmon-colored elements are the alkali metals. Hydrogen is a different color. Alkali metals are very, very reactive. In their pure state, they will explode in water. Each one of them will do that. So that's a property they have. They're all very, very reactive. Alkaline earth metals we're showing in this next column. So group 2 are the alkaline earth metals. They are somewhat reactive, not as reactive as the alkali metals. They don't generally explode in water, but many of them do react in water. So not as reactive, but the reaction they do have is similar. And we'll see, I should say we'll see in a little bit, we'll learn a little bit more about what that reaction is later in this module. If we come down to the other side, I'm going to start on the far end. We have the noble gases, so group 8A are the noble gases. These elements are very non-reactive. They tend to not react with things. You can kind of force a couple of them like krypton and xenon to react if you try hard enough, but they generally are non-reactive. The halogens, however, are very reactive. These react in a very different way than the alkali metals. These are things that are kind of tend to be poisonous more so than explosive. In fact, these are as we'll learn later, these are kind of the things that will lead to the type of explosion you might see over here with these. So these would be very good at reacting together, as we'll see. So these 4 groups have special names. And then in addition, this entire section, so not a particular group, but all 8 of these groups have, all 10 of these groups have a special name together. These are the transition metals. And so you can remember that these are the ones that are kind of sunken lower on the periodic table are the transition metals. We'll learn a bit later about why this particular pattern shows up. And then I want to talk about these elements down here. So just in terms of why does it look like they're floating in space? They're not kind of connected to these other ones. They are actually connected. They're connected right here. So we have, and we'll talk in a bit about what these numbers mean, but we go 57 and then 58 up to 71 and then back to 72. Here we have 89, 90 through 103 and then back to 104. So these are not separate or lower than the others. We're just basically making a space for them because the size of a screen or a piece of paper is such that it's easier to do that than have this thing be basically twice as long, almost twice as long as it already is. So this is a way of representing that. So we call these the lanthanides and these the actinides, and that's based on the first element within the series. Here these are more kind of aligned as not the whole period, but a portion of the period, as opposed to the groups we've seen for the other arrangements. And there is a bit of a reason for that, but for now just understand that it's a convenient way of talking about the ones that are down here. Sometimes these are called the intertransition metals. So just be aware of these various regions of the periodic table. Okay, so that is it for module 1.1. So go ahead and complete worksheet 4.1. If you have any questions on this material, ask them on the discussion board, and then go on to 4.2 when you are ready.